I will be the host of this meeting, and we are excited to have two wonderful, actually three wonderful guests with us. Megan Ma, who's a doctoral student in law at Sciences Po Law School in Paris, and Dimitri Bodkopayev, who's a senior legal data scientist at Siemens Wavelength. They will talk about deconstructing legal text and object-oriented design in legal adjudication. And then we have Landon Stinson, who is a co-founder of Candle, which is an enterprise software that helps law firms improve efficiency. And so we're excited to hear from our presenters today. We have an hour as every week for this meeting, so we'll split it right in half and give each presentation half an hour. But if the presenters could stick to perhaps 15 minutes of presentation and leave the rest for discussion, that would be great. And before I turn it over to Megan and Dimitri, I wanted to see if anyone in the group had any news to share with the rest of the group. If so, please go ahead, speak up, or use the chat function. Actually, I'm getting a question from someone in the group. We do record these sessions, and we put them in our YouTube playlist, the CodeX playlist on YouTube. So as a recording will be available probably in a week to two after this session. So anyone else has anything to share with the group? Okay, doke. So then let me turn it over to Megan, who I can already see. Hey, Megan, how are you?
Hi, I'm doing great. Thank you. How are you doing?
Good, good. Yeah, we're excited to learn about your work, and I will just turn it over to you.
Great, thanks. I'm just going to share some slides. Can everybody see?
Yes.
All right. Okay, so let's begin. So hello, everyone, and thanks very much for tuning in. And again, a special thanks to Roland and Susan for extending such a kind invitation. We're obviously thrilled to be here. So by way of brief introduction, my name is Megan, and alongside Dimitri, we represent our small interdisciplinary team of 4. We hail from humanities and sciences, specifically the fields of mathematics, data science, linguistics, and law. To start, there is an ancestry of applying mathematical precision in legal reasoning. In fact, Gottfried Leibniz and George Boole were amongst the most famous logicians who sought to give clear parameters to interpretation. Our research asked a simple question: what is the significance of meaning in legal language? This question was tested through the translation of legal text to algorithmic form. We hypothesized that meaning draws association from the language in which it is stated, that in changing the language, meaning will naturally be reconceptualized. Using a selected set of judicial cases from the Supreme Court, we deconstructed sentences of legal judgments to their constituent components. 3 cases were selected: Smith, Bailey, and Muscarello. These cases were evidently cherry-picked. They come with caveats. Namely, the statute in question was subsequently amended following these cases. Nevertheless, they were chosen for reasons that made them great test cases. First, they had a similar factual premise. This involved defining the use and carry of a firearm in connection with a drug trafficking crime. Second, they were ruled in rapid succession. As you can see, Smith was ruled in 1993, quickly followed by Bailey in 1995, and in 1998 with Muscarello. So leveraging the team's interdisciplinary knowledge, we used a combinatory method. Sample sentences were drawn from the full decisions that were revealing of legal concepts from the text. These were definitions that were gathered from judicial interpretation. Applying then linguistic theory, in particular dependency syntax and the classical theory of concepts, sentences were marked for their bare structures, developing rules to deconstruct sentences. Natural language processing technology was then used to parse the sentences independently. The combined relative precision of syntactic structures and broad statistical modeling of context demonstrated that hybrid techniques provide a deeper understanding of legal text, both in conceptual framing and in semantic interpretation. We then use Neo4j, a graph database, to store our outcomes. So how does object-oriented design play a role? What we noticed, of course, is the complexity of legal concepts, having the possibility of multiple meanings or polysemy. For this reason, we wanted technology that would cater to non-singularity. Graph databases generate highly interconnected webs of knowledge, optimizing analysis of relations between data points. The intention? Well, in breaking down natural language phrases to their skeletal frames, it forcibly exposes connections integral to the formation of concepts. Applying a hybrid technique of linguistic and natural language processing technology, we advance beyond existing methodology to harness both rules-based and data-driven technology to the translation process. I now turn it over to my colleague Dimitri, who will take us into the technical background and implementation.
Hi, everyone. Great to be here. So let's dive a little bit into the tech underlying our project. So the technical background is that the most recent and seemingly significant advances in the parsing of natural language have primarily harnessed quote-unquote brute force statistical modeling techniques, which depend on vast amounts of training data. Your word2vec, your transformer technologies, GPT-2.3, BERT, I'm sure if you're in the space, you have heard of them. The extraction of semantic content from text, however, does leave room for improvement and cannot, in its current form, be adopted in an industry that is so heavily invested in this aspect of language-based communication. What we are aiming to do is to, by translating legal documents into an object-oriented model, to create a framework that can be navigated by an automated or human observer. At this point, I would like to ask Megan to show the next slide. Thank you. So as you can see on the left, we have the training stage. On the right, we have the usage stage. Essentially, how would the usage of this work? We would have a trigger, i.e. input text in the form of a query in natural language that would get translated into input data, meaning the abstractions and metadata meta-concepts such as the grammar, in a similar way that we did the training of the object-oriented model. Then we would take this documented algorithm and compare it to what is present in our model. So this would allow one-to-one comparison of the grammatical structures and content within both. The output data then would be a condensed form of relevant information based on intent, contradiction detection, and most relevant statements. As in effect, what you would get is a way for the user to zero in on the most relevant data, improving their efficiency of processing legal information, and the ability to conduct such things as testing, so collision testing, A/B, loophole detection, and so on. Going on to the next slide, consider the sentence, I use a gun to protect my house, but I've never had to use it. So I would like to ask you to forget all context and think of the following sentence with the Cyril's Chinese room paradigm in mind, roughly the way a computer would ingest such an input. It is a common notion among linguists that the transmission of information through natural language pivots on the structural distinction of subject-predicate. This is universal across natural languages in one form or other. We have SVO languages, VSO, and SOV languages. Essentially, our subject, verb, and objects are always present. The order may be different, but the structure remains the same. So in a nutshell, the SVO triplets, such as those in the English language specifically, can be seen as to be the most granular unit of reasoning in natural language. Looking at the first part of the sentence, to illustrate this point, we can, if we break it down into nouns and verbs, we find the entity I acting upon another entity gun by way of use. Such a breakdown translates nicely onto the concepts of classes, class instances, as well as class methods as used in the object-oriented software design approach. If we scale this approach up, we get an increasingly complex network of triplets. So on the next slide, you will see the sentence broken down into this more nuanced model. So when we evolve our approach, we are creating a highly interconnected web of reasoning units or reasoning bits based on these SVO triplets and their subject and object abstractions. Similar to a human parsing text without the benefit of vocabulary, but with the knowledge of grammar. At this stage, it is already possible to navigate the query or rather navigate and query the network under the assumption that the unique spelling of a word defines its meaning. Adding nuance to the network is achieved through the introduction of metadata, such as word embeddings, as well as other semantic and syntactic phenomena. The network becomes more intelligent. Analysis of the graph can then be done by localizing the entities and/or events within it, looking for patterns such as SVO constellations, and supplementing the network with additional context source feature engineering. When regarding the reasoning network as an algorithm, the grammatical structure becomes de facto the computational graph. On a small side note, in this particular example, for instance, you can already see some insights. For instance, the fact that recursion can roughly be seen as proto-causality, as linguists would put it. That is to be refined at a later stage. As for the technical implementation, we're using a combination of pre-trained and blank or custom estimators, for instance, for detecting the SVO triplets, in an attempt to generate an enriched data set that will enable us, through the use of graph databases, to model and understand the logical structures underlying the statements encountered in our source documents. The development of this process, essentially, we are hoping will result in a hybrid model of reasoning. This is a combination of inductive reasoning, similar to the statistical estimation inherent to neural networks, and deductive reasoning, which is purely analytical based on the extraction of grammatical structures within the text. One analogy we like to use is the interaction between the left and right hemispheres of the human brain. The concepts behind the parsing algorithm work similar to the process of learning a new language. There are rules that apply in a majority of cases, then there are overriding exceptions. By reading the text, the algorithm sequentially builds itself an agnostic world of entities. These are abstractions represented by a noun and surrounding metadata, and their interactions with other entities in this containerized environment. For instance, triggering or affecting an action, assigning, unassigning information, building other logical structures. Semantic elasticity, or intuition, is learned, much like the mechanism underlying the training of neural networks, through ample experience and enriched information. The more exhaustive, the better. Up to a point, the data, those of you familiar with data science will no doubt have heard of the phenomenon of overfitting. This is when your semantic structure becomes a bit too brittle. Of course, we cannot discount the inherent ambiguity in the output of this method. However, this is an omnipresent problem, not just in human language, but consciousness and reasoning as well. To illustrate this hypothesis, one may look at the phenomenon of humor as an example, which is often manifested through the deliberate use of semantic and other forms of ambiguity. I will now hand back to Megan.
Yeah, so some of our early findings seem to illustrate that the words of legal text intrinsically embody meaning. In fact, the legal language is markedly self-referential. However, meaning is not logically deduced or syllogistically applied. Instead, meaning is extracted. The semantic content of legal text is derived from a legal taxonomy that in effect substantiates a specific legal framing. Adopting the decisions of the past to guide future conduct parallels this exact act of extraction. That is, applying past precedents provide the scope for a gradual molding of rules to meet fresh situations as they arise. So interpretations of the past carry the definitions used moving forward. So perhaps we can conceive of the role of the judge as an archaeologist, excavating legal truths from judicial pasts. On this thought, we will now turn to our short demonstration.
Okay, Megan, if you could please stop sharing. And yeah, thank you. So, this is the model of the database as we have it so far from our documents. As you can see, per the previous slides, we have documents, noun chunks, phrases. We have begun to extract quotes, bracketed phrases, SVOs, and tokens. In this particular case, this is an SVO. This is specifically the phrase that we had used before as an example. I use a gun to protect my house. So as you can see, we've got an SVO and another SVO that is dependent on it. We have our noun chunks that are connected to our tokens. And essentially, all of these are also part of a specific quote. Moving on, let's use the SVO structures to cross-reference the usage of the entity firearm with the modular verb must. As you can see, we have three results which have a varying degree of similarity. This similarity metric is based on word embeddings and a simple cosine similarity comparison. So let's take a look at the actual phrases. And as you can see, the phrase in Bailey is the phrase that we're trying to compare all the other phrases to. And here are our results. At this point, I will ask Megan to elaborate.
So what does this mean from the legal perspective, right? So from the legal perspective, there's this desire for consistency and coherence in the law. Whether Hart or Kelson, legal theorists have spoken of areas of certainty and uncertainty in legal interpretation. What we aim to identify is these areas of certainty, consistency across legal judgments, while the areas of inconsistency, we use this tool to help deepen the analysis of those areas. Here we look at sentences drawn from cases of Smith and Bailey. The court in Bailey cites Smith, stating that the active employment of a firearm is equivalent to the operative factor in the drug trafficking crime. In Smith, the court simply determines that the firearm is not the result of accident and has the purpose of facilitating the crime. The question becomes, is the definition of active employment consistent with not the result of an accident or a purpose of facilitating? What the tool here has done is that it's isolated these sentences, showing that there is sufficient similarity between them. Effectively, it clarifies the role of the firearm by building the connections around the legal definition of the use of firearms through what? The modal verb. We start with our reference sentence 41 from Bailey. Here we find that there's relevant connectors with sentences in Smith, namely 31, 8, and 7. What does this suggest then? Well, as opposed to other meanings that may be associated with active employment, this permits a deeper analysis, such as, what is the specific intention of the court to narrow or qualify the definition of use with active employment? Or is it not sufficient to define use of firearm as just not the result of an accident? Why is the clarification necessary in Bailey? So if we turn over to sort of our concluding kind of statements, our goal here is simply to strengthen the understanding of legal texts. We want to provide better roadmaps and signpost users towards more consistent interpretations of judicial decisions. We thank you very much again for your attention, but before we turn to questions, we would just like to give a shout to the rest of our team who are with us here today, Adam and Avalon, who have been helpful in the linguistic and mathematical perspectives.
Hello. Hi, guys.
Great. Well, thank you so much. This is super interesting and very impressive work that you guys are presenting here today. So very, very cool. And so the folks already have some questions in the chat. Maybe I'll quick question. So is this part of your doctoral program or?
So it came as an offshoot of my thesis. So I am working on the broader question of sort of the significance of legal language and analyzing a variety of rules-based and data-driven technologies and how that changing sort of the medium. So moving from natural language to different programming languages have an impact on the operation of the law. I was in Cambridge shortly for a visiting researcher position, and I had gotten to know Avalon, who's part of our team, and he then introduced me to Dimitri, and so the rest is history. So it kind of grew organically.
Okay, great. Okay, so Anatoly is asking, do you have to manually build that structure shown, or the system automatically creates it? Amazing product from what it looks like. Wish you guys all the best.
So I think I will answer that. So yeah, currently the database that you see here is built based on our markup. However, one of the things that we are doing is we are intending to have an ensemble of classifiers that are able to do this automatically from natural language. In essence, this is a dependency tree parse with additional metadata that can be infused using named entity recognition and text classification. It's an ensemble of models that parse in and create the data.
Okay, is there any way, I mean, how would you compare it to existing methods of processing legal text? You know, if it's your, I understand that you're connecting a data-driven NLP approach with the rules, and is there any way to sort of compare, you know, sort of recall and accuracy in any way? Have you done that? And if so, what?
So there are, since this is an ensemble of models, most, if not all, commercially available natural language processing methods nowadays, at least in the legal industry, they pivot on leveraging and training word embeddings in one way or another. This is a statistical method, whereas what we are doing is we are using several statistical methods to estimate different parts of the graph and then putting them together. So I want just a single measure of precision and recall at this point would make little sense. We could, for instance, compare the parsing of the graph. So basically the grammatic structuring, how accurately a dependency tree is built. Which is currently, I mean, without having done any real data intensive training on the models, just using out of the box, we are essentially at 90+% for grammatical parsing. And this is roughly, I would say I would attribute it to half being the not problems or issues, but inaccuracies within the model, and the other half would be inconsistencies within our markup, because obviously the linguistic side of the question, it's linguistics are not a science, they're more of an art. Right. And this is where there's several different approaches, and this is one of the things that we discuss on our weekly call. We have debates on what approach to use when tackling one problem or another. I mean, Adam could elaborate on this if you'd like.
Yes, can you hear me?
Yep.
Yep.
Great. So I'm the resident linguist, and one of the useful elements of being an interdisciplinary team is that we can draw on our core elements of our fields separately. And so when we come across a difficulty, for example, what type of syntax trees to use, I've already been there as a linguist, and there are several approaches to choose from, and we simply cherry pick the approach that we know is going to cause the least problems in the long run. For example, dependency syntax was most favorable for us with our system for various reasons, to do with predictability and low redundancy in mapping.
As opposed to, for instance, using X-bar theory.
Yes, as opposed to, for example, using a phrase structure constituency syntax, which has a lot of redundancy, and also the dependency syntax is based on the verb. The root verb is the height of the hierarchy, whereas with other systems it isn't. And for us, that was favorable.
Okay, great. So we have about 4 more minutes and 5 more questions, and. Yeah, I don't think I have to enforce the time as rigorously as in a presidential debate. So, but Matthew's asking, what's the use case? How is it better or more economical than having a human do it?
I think perhaps I can start, and Dimitri
Sure.
will take on from a different perspective. So from a legal perspective, at least, what we saw is that we didn't show it here, but we noticed that it's a kind of more nuanced and deeper analysis of specifically precedent and the use of precedent between legal judgments. And yes, it is clear that there is sort of application of past case law, and those who are involved with the legal field have practice in doing that. But what we noticed, and especially between these 3 cases, is that often we miss on some of the inconsistencies that actually exist in the law. And for example, in the Smith case, they consistently repeat and talk about not reading provisions of statutes in isolation, that they have to be read in whole. And what we noticed actually was in the dissenting opinion of the Mascarello case, it appeared that the dissenting judge had reiterated this point, but the opinion of the court actually applied a truncated version of the statute, meaning that they didn't read the statute in full and actually read parts of it in isolation. So here we're kind of trying to show that while kind of using a sort of human reasoning of applying past case law and applying precedent, with kind of a tool being able to already sort of do the early groundwork, we can have a richer or more deeper analysis, if that makes sense.
Yeah.
I would add to that, zooming out on the use case, this is we see it as potentially having the application of your normal natural language processing algorithm plus the reasoning bit. So everything that comes with it, meaning, are we looking for a root cause analysis or maybe contradictions within the text? It's possible to, this can be the step that bridges the gap between natural language and pure algorithm. So if you look at it in this way, essentially what we're doing is we're building an object-oriented application from the text. So it's a object-oriented picture of the environment that is built within the text with all the outflowing ramifications, so to speak. So as I've mentioned, you could test a hypothesis just like you do unit testing in code. You could substitute each of these entities with a piece of code. I mean, specifically the SVOs. These can essentially be a code in a smart contract that takes specific inputs and delivers a specific result. So this is basically essentially bridging the gap between natural language and algorithm.
Mm-hmm. Okay, great. So so I don't think we'll have time to go through all the remaining questions, but perhaps Megan, I don't know if you saw the questions in the chat. Did you have a chance to read them?
I did, but
Maybe
there's quite a few.
Pick the one that you would like to answer, and then perhaps if you could share your and Dimitri's email address in the chat so people could then follow up with you directly.
Yeah, sure. I guess the following question is from Bruce. He asked, how might Black's Law Dictionary be another data source? It's a great data source. At the moment right now, we're looking specifically into legal judgments, and we're looking at specifically the tool of precedent. So while Black's Law is great in terms of narrowing in on definitions, we're trying to sort of extract definitions from judicial interpretation specifically. I guess we can also leave our email.
Yeah. You have maybe time for one more question then, since you were so quick now. Yeah, this is interesting. So Raja, what's the main advantage you have querying decisions with a graph rather than with traditional information retrieval methods?
So I think I could take that one on.
Yeah.
The advantage of querying a graph is essentially the fact that the queries that you create are flexible. Coming back to, as you were asking, this is the email for the group if anyone wants to contact us with questions later. Let me just exit the presentation and show you the example. So this is a query of a graph. All you have to do is essentially substitute these two words, and it would find all the connections. You could create any sort of path between the two words, whether it's a noun chunk or whether it's a token. It can go from here through any sort of constrained path. That allows basically for the flexibility rather than traditional relational databases, where if you wanted to get from one data structure to another, you would have to create a join. Then if you would want to get to the next one, you have to create another join, and your query snowballs into huge, well, garbled mess. Anyone who has ever worked on a data warehouse file for a big multinational company will know what I'm talking about. This approach allows us to model different hierarchies in very different ways, in very flexible ways. It allows us to create connections between any node, well, any type of node to any other type of node. It allows us to make connections of nodes to themselves, and so on and so forth, creating different paths. This would be similar to the paths that the impulses inside your brain take between the different neurons, or the signal propagation within a neural network. The only difference between this and the neural network is the fact that a neural network is more like a lattice, a fixed lattice of neurons, whereas this is molded by the input data.
Interesting. Well, good. Well, thank you again. So this is very, very interesting work. There's a couple of other questions that I think are also very interesting. I would love to have explored, but unfortunately we don't have more time. So I would encourage you all who have more questions for Megan and Dimitri to reach out to that email address that they just shared. core.svo@gmail. And thank you so much for your time and for joining us. Where are you joining us from? Are you actually in Paris, or where?
I'm actually in Vancouver right now. But just as a final note, we put on our slide that our paper is up on arXiv, but actually we're sort of pleased to announce that it's been accepted for publication with the MIT Computational Law Report, and this is forthcoming. So if anyone's interested, they're welcome to head over and read the whole thing.
Yeah, and Daza, I think, is here on the call too, and from MIT. And so, yeah, congratulations on the publication, and thank you again for joining us. Please keep us posted on the progress of this project. It's very interesting work.
Thanks very much for having us again.
All right, good to see you all. All right, so let me turn it over then to our next speaker, who is Landon Stinson, co-founder of Candle. Landon, are you there?
Yes, I'm here. Hi, Roland.
Hey, there you are. Good to see you.
You too.
Where are you located?
I'm in Gainesville, Florida. My wife is doing a PhD at University of Florida, so I'm here supporting her.
Wonderful. Well, thanks so much for joining us. And yeah, I'll just turn it over to you. And we're curious to learn about Candle.
Thank you, and thank you, Megan and Dimitri and team. That was really thrilling stuff, and I'm excited to see what happens with that. So thank you very much. Can everyone see my screen?
Yes, we can.
Okay, great. So closing the medical record, what we call the medical record vortex, is vital to enhancing access to justice and helping lawyers help their clients avoid a financial peril. And I promise that will make a lot more sense in about 6 minutes. My name is Landon Stinson. As Roland was saying, good afternoon. The genesis of Candle, just a brief background, is actually from a law school internship. I went to BC Law about 3 or 4 years ago, and I would take the train to the basement floor of this building in Boston, downtown Boston, and I would go to this windowless room in this law firm for an internship, and all I would do is just request medical records and bills all day for about 60 to 70% of the time. Pretty grueling. And I found out from that experience 2 things. The first thing is that medical records are very important to people. Medical records and bills are vital for people to move their legal cases forward. And we view it as a basic human right for people to be able to access that information legally and securely. We also believe that right extends to that person's attorney, should she or he choose to hire one and give them permission to access that information. The second thing we learned is that it's extremely difficult for people's attorneys to access their health information. And so 3L started, and I couldn't shake these 2 thoughts and ended up partnering with some developers, and we've grown our team. And now 3 years later, we're a technology company with an app on the Clio app directory. And so today I'll just talk for about 12 more minutes about 2 things. Number 1 is the problem that we're seeking to solve, and number 2 is the solution and how we have attempted to solve this problem. So first, we'll go into the problem. So we can start at the first principles of the legal side of this. And I am an attorney, so I have to give the annoying caveat that this is not legal advice. This is very overly simplified. So personal injury cases have probably hundreds of phases and steps, but I've broken it down to just 4 broad phases for the purposes of this presentation. And so the first phase is that someone unfortunately gets into an accident. And so say you get in a car accident and they break some bones. And so the next thing that would happen is that they go into phase 2. And phase 2 is they receive medical treatment. They receive medical treatment from a number of different facilities and accrue data at all of those facilities. And then say they hire an attorney to help them. And then they move into phase 3, which is where their attorney seeks to retrieve all of that data from the facilities that they've been treating at to use it as evidence. So the medical records and the bills are evidence that the attorney will then package together and then send this evidence to the opposing party and seek and demand compensation for their client. And then step 4 is where it's all ending, which is through a trial verdict or a settlement, and it ends in a check. So I want to briefly stop and just acknowledge that this is much more than just money to these people that are involved in these cases. This really is justice here. And the reason why that is that if you're involved in an accident and you don't have health insurance, for example, and you're injured to the point where you can't work and you have children and you have rent to pay, it can be really disastrous. And so your only lifeline, if you don't have a community of people around you, is the check from the opposing party's car insurance. And so we really focus on this third phase here because we believe that anything that gets in the way of people getting this justice is inherently a bad thing. And so we're trying to make this as efficient as possible. So just to demystify what a medical record request is, it's just two documents. It is an authorization that the client has signed, giving the lawyer permission to get the medical records, and a cover letter from that lawyer that basically states that, hey, I'm this person's attorney, and I'm seeking their medical records for a case. So when you think of medical record requests, just know it's those two documents. And so this is really some legal document management research that we've been doing. So let's take, for example, this is a Tesla, right? Teslas need electricity to move forward, to accelerate forward. And similarly, let's take, for example, Leslie on the right there. She's a managing partner of a personal injury law firm. Her firm needs their clients' medical records to move cases forward. Without medical records, the cases cannot move forward. So it's very important to attorneys. The problem comes in where, and this is what I learned in the basement doing the record request during the internship, is that it's a very tedious process to request these records. So you have to get the client's authorization. You have to make the cover letter. You have to find the contact information for the facility. You have to either fax, mail, or submit the request to a third-party site. You would save it in your law practice management software, Clio, for example. You then have to log this so you can manage all these documents and keep up with your efforts. You often have to call the facility then to follow up on the records. And sometimes you even have to send follow-up requests. It's very often we've seen our users have to do this. And then you have to log it again. So it comes out to about 9 steps. So for one client, you actually have up to 15 requests. And the reason why that is some people don't know this, but take Hospital One, for example. Hospital One silos all of your medical data into different places. And so to order records from the medical record department, you have to send a fax to fax number A. To order bills from the billing department at that same hospital, you have to mail the request to address A. To get the doctor's bills, because doctor's bills are separate from hospital bills, because doctors are often just contractors at hospitals. You have to send it to fax number B. And then to get the radiology records, you have to mail it to address B. And so you have 15 requests just for this one client with 2 documents per request. And so at Leslie's firm, she has 70 clients. And so she has 1,050 requests, or over 9,000 steps that her and her staff have to do. And so it just becomes a legal document management nightmare for these firms. It's a really big problem. So why are medical bills important? Well, according to a study by Harvard University, medical bills actually contribute to 62.1% of bankruptcies in America. And you would probably be surprised, or unfortunately maybe not surprised to know, that over 50% of those bankruptcies are people who had health insurance. And so when someone gets into, it's more than just the lawyers on the billboards. When someone gets seriously injured, the statistics show that they are at risk for financial peril. And so Leslie's clients, for example, each client will have 9 medical bills. There's different insurance companies, there's health insurance, car insurance. There's a lot of different bills that Leslie has to keep up with at her firm. And then at the end of the case, she has to help her client decide what bills still need to be paid and what don't, so they don't hurt their credit score. And so Leslie, again, has 70 clients. That's over 630 medical bills that she is having to juggle around. And she knows that she is the one that's legally responsible she has a duty as an attorney to make sure that her clients' bills don't go in default, and to make sure, and oftentimes lawyers will call facilities and negotiate down the bills. So it's a lot to keep up with. And at the end of the case, if Medicare and Medicaid has paid on bills, for example, there could be a lien. So she has to organize and decide which liens need to be paid out of the settlement check at the end. And so this is overall bad for firms. Leslie's firm experiences angry clients, wasted time and money, and the employees, frankly, from someone who was doing this during law school, this internship, it really does lead to burnout because it's a really tedious manual step. And this is what I was talking about. This is what we call the medical record vortex. And there's a lot of firms. So an academic has said in a white paper that there's over 90 million of these medical record requests for legal per year. And so we see firms all over the country that are dealing with this legal document management problem. So the question is, can we close the medical record vortex? And here's the solution that we have. And so, like I said, we do have an application in Clio. And so our users see 3 different screens: the request screen, the manage screen, and what we call Billy, which is the finance dog from Harvard. For purposes of this talk, we'll say the finance dog from Stanford. It's a little more relevant. And so I'll show a short demo on my screen. So this is a user opening up Candle in Clio. So they have a list of providers shown, and instead of all those manual steps, they're just completing it by clicking buttons, just like a TurboTax type solution. So all they have to do is upload the authorization and they can send out the requests. Now, instead of doing all of those 15 requests separately, our users can send out all 15 requests at once. And this is obviously sped up. It's just to show you that they don't have to leave this screen to send all of their record requests. So after they sent the request, it easily organizes them for all the requests for the users to be able to keep up with. And then the user can then add new facilities so they can grow their firm's database. And then this addresses the part of the problem with keeping up with the different bills all at once. And so the users can easily go in and track all of these bills using this spreadsheet type screen that we've created. And they're able to easily go in and once they get the bill, track how much is left on it, what they need to pay. And we find our users really enjoy this feature because it gets rid of all the pressure of not knowing what's where and using manual spreadsheets to complete these tasks. So this is our team, some of which are on the call today. This is Jordan, who's been instrumental with Candle. He is basically an ops genius. He's a former analyst at an MIT-based spinout called Profitile. We have Arjun here. Arjun is a brilliant developer. He's basically coded our entire application. He's the one I contacted in 3L. He's a full stack developer. We have Taylor Fallman, who is an AWS wonderkind. He's basically making our app very scalable and doing our backend stuff. We have Meredith, who is our what we call a chief data analyst. She's a master at SQL and just very talented at helping us stay lean and learn from our users. We have 2 advisors. One was the former CTO of pathology at a major health network, David Nessel. David Messias is the co-founder and CEO of Shadow Health, which is an ed tech company. Rachel Lang, it leads up our customer service team. And then we have Michael and Janelle, who are record request experts there that help us facilitate some of our backend. So how are we different? Because other people have obviously tried to solve this problem. So what we're trying to do is really democratize this for our users in a secure way. And so we, all of our data is encrypted from, it's encrypted in transit. It's also encrypted at rest. We use a 256 AES level of encryption, store all of our data on AWS. And we charge a much lower price as opposed to the general service-based solutions. And so because we're able to automate this process, we can get it down to $2 to $7 per request, as opposed to the general service-based manual solutions to this. People outsource it for around $35 per request. So we're trying to make sure that even when cases don't have a super quote unquote high value for attorneys, those clients still get a premium service because the attorneys have the option to use our automated software to increase the efficiency of this legal document management project that they have. So I'd be happy to take on questions now. I know that I've gone a little bit over time.
Great. Thank you, Landon. Very cool also. So that's what I love about these meetings is that we can have a presentation that's very much on, some using technology to ask some very theoretical questions about how the law works and operates to someone like you who uses technology to solve a very real and concrete problem. It's something that you experienced yourself, which is always a good starting point to launch a company. So this is very cool, and it's I think it's something that that a lot of attorneys working in the space, but also individuals who are injured, will benefit from. So so Dasa is asking. Hold on. Let me back up. 1 second. Oh, okay. So so Mark's asking, whether you're funded or whether you're actually seeking funding.
Thank you. We're actually pre-seed right now, so this has been a bootstrapped effort so far, but we're currently putting together our first pre-seed round.
Oh, I see. And that would be so for angels mostly.
Exactly. Yep.
And not institutional money just yet. Great. And can I ask, so how does it work on the hospital side? Do you need to get hospital medical records organizations to to start using your platform to receive the request, or did you create a workflow where you sort of, you've done everything until that point to make it easy, but then you still have to fit into their specific processes?
Yeah, thank you. So we don't work with hospitals, and the reason why is that there are health information exchange software programs that exist, and they kind of are up against a network effect, right? So the telephone is only valuable if someone else on earth has a telephone as well. And so we attack this problem in a different way. So instead of having to convince all of the providers to join a platform and then bring the attorneys to that platform, we just did a one-size-fits-all solution for the attorneys and for the law firms. And so they can request records from any facility they want. And then further down our product roadmap, we plan on creating an application on the Epic App Orchard for hospitals to be able to process these requests faster.
Okay. Can you talk a little bit about how much uptake you already have? You're on the Clio platform, which is obviously a great place to be when you want to reach lots of firms. What sort of uptake do you see?
Yeah, I do want to mention we really love Andrew Gay at Clio. He actually went to Stanford as well, so it's cool that this is his alma mater. Yeah, so since I think our first request went out in March of this year, that's kind of when we really started to see an uptick. And at this point, people have sent over about 1,700 requests through Candle.
Oh, okay, great. And let's see. Scott's saying, thanks, Landon, and great. In closing the medical record vortex, and as example, you have to ever, I'm sorry, my computer's just closed the chat here. Give me a second. I'll have it again. Do you ever have to reach out to Epic? You just mentioned it, which with related companies may support 50% of U.S. hospitals. And how would Candle request work as another example with Kaiser Permanente health records in its 8 U.S. states?
So the question was, have we been in talks with the company Epic with the? Yeah.
And would it also work, would your system also work with Kaiser? And I assume you just said you're not really integrating with the hospitals.
We're not. So the way that we chose to approach this was to first just do a one-size-fits-all solution for the law firms and complete the request the way that all of the hospitals require the request to be completed. And so if you receive medical treatment at 5 different hospitals, there is a high likelihood, based off of our findings, that each of those hospitals will have a different method of sending record requests. and they require record requests to come in that way. And so Epic is an electronic health record platform that hospitals use. It's like the Clio for hospitals. And so we chose to just meet hospitals where they are and get lawyers using our platform. And then as hospitals create API endpoints, or as we integrate with Epic App Orchard, our users won't really know the difference. They'll just know that it's a lot faster because we're now integrating directly with the facility itself.
Got it. Bruce is saying that it feels like Candle would be a great parallel offer for credit watch services and personal financial management. Bruce, can you elaborate on that?
Yeah, since health, wellness, and financial wellness are inextricably tied together, given the reimbursement saga that we go through in getting medical bills paid, it feels like Candle should keep up with medical reimbursements, and then the patient side version of, well, whether treatment was effective or not, and in fact harmful. So it would seem like if you have medical bills coming up and there were problems with the service, that the patient should be able to, in real time, look at the enormous paperwork of billing and annotate for themselves the issues, so that they can then, if there is a medical malpractice or other claim, have their current memory of the problem rather than a faulty memory of the problem. Or if it's a relative, that person could be incapacitated and not be able to give that evidence.
Yeah, thank you for sharing that. I think there is a David and Goliath situation here, where right now when people get billed for a procedure, they just think that they just have to pay it and shut up and that's it. And so I think empowering patients to take charge of their medical financial situations is something that we have. So as a big picture, our roadmap is to go to market with legal and solve that David and Goliath situation of lawyers dealing with this huge legal document management problem of requesting to facilities. Number two, go to facilities via the Epic App Orchard and allow them to fulfill these requests faster. And then number three is we hope to do a direct digital health consumer-facing product to help users really be assertive and take charge of their health and financial related issues, sort of like a rocket lawyer for negotiating your medical bills.
Yeah, I would love to speak with you more about that. So we have been focusing some energy on the space of computable contracts, and we think that self-executing contracts will help, particularly in the insurance space and specifically in the health insurance space. Provide for more transparency, more speed of processing, and so I think that's that is a I think we're also motivated in that sense that you want to create something that ultimately helps the individual consumer or injured party better understand their rights and get faster, get their recourse faster. So, all right, so we have 1 minute left. Is there one more question that anyone has in the group?
I'll go ahead and chime in here, following up on what Roland said. So Landon, you may want to think about, there's a lot of energy in the insurtech space, and there's a ton of startups now, and some of them are more focused on like consumer equity and that kind of thing. And there could be some partnerships there possibly to check out. One big thing when it comes to equity is, since there's so many new entrants in this space, offering things like, car insurance and that kind of thing, this might help bring their subrogation costs down to the point where they might be able to serve higher risk drivers, and so may be able to provide insurance for a greater portion of the population since it brings their claims costs down potentially. So that might be one future application of this kind of service. But tremendous service. Thank you for providing it.
Yes.
Yeah, thank you. Thank you very much.
Yes, I very much agree. Thanks, Susan. And that's a good suggestion too. Landon, it was great to have you. Thank you so much for sharing your story, and this seems like a really great group of people and a great problem to solve, and it seems like you're making great inroads there. So very excited to learn about your work, and also Megan, if you're still there, thank you so much to you and your team for joining us and for sharing your work. Two great presentations today. Really thought it was very interesting, and I'm excited about all your work, and you know, we're cheering for you. Please keep us posted, and yeah, next week, are we meeting next week, Susan?
Yeah, so I'm going to drop into chat. We're actually having a few CodeX events coming up in October, so people can learn more about that on our website, or if you're not already signed up for our other mailing list and you want to get even more email from us, go ahead and sign up and you'll get these announcements for our other events pushed to our mailing list. But for our next 2 weeks, next week we're going to have Meet CodeX. We already have more than 260 people signed up. So we'd love for you to join the crowd. That's next week. And then the following week, we have one of our affiliated CodeX faculty, David Engstrom, who's a professor at our law school, is going to be speaking. So we'll be back with a CodeX group meeting on October 29th. So we'll be sending out an announcement that week so you know who our presenters will be.
Fantastic. Thank you so much, Susan. Thank you all. Thanks for joining us. Great session. Please stay safe and go and vote. All right.